Okay, so we'll be talking about the Envidas Ultimate software. Um, so there are four main components of the Envidas Ultimate software. There's the Envidas Ultimate Setup, the Envidas Ultimate Viewer, the Envidas Ultimate Service Manager, and the Envidas Ultimate Reporter. There is a fifth application, the camera view, that's not used as much. It's used if you have cameras at the site. It's like a camera viewer utility similar to a DVR that allows you to view those cameras remotely. Um, the first piece of software, the Envidas Ultimate Setup, it is used to configure your site, configure your instruments, your channels, your users, etc. The Envidas Ultimate View program is used to view live data that's coming into the system. So your data points, your live diagnostics, your live digital statuses. Um, and then you have the service manager. Um, it is this application that's running at the bottom here. If it's red, that means the service is not running. And if it's green, that means it is running. Sometimes it won't be displayed there. So if you click this up arrow, you can just drag it down. Um, so the software runs as a Windows service. So even though all of the applications are closed, as long as this globe is green, that means it's actively collecting data in the background. So this application controls the service called Envidas Pull that's listed in the Windows services. As you can see, its status is not running currently. If we were to right click that and say start service, it would say that it's started or running here. And then finally, you have the Envidas Ultimate Reporter. It is used to display historical data. If you wanted to look at a cow that ran, an hour ago or yesterday, you would use this application. Or if you wanted to look at the historical data, you would use the Ultimate Reporter program. So we'll start by going into the Ultimate Setup application. So we'll go ahead and launch that. And we're presented with the login here. In this case, for this demo, we just put the username and password the same, just drdavs. So currently I'm connected to this database that I was testing for the purple air. I'm going to change it to the database that we created for this demo. And it was just training one. I'm going to select it and say save, and then I'm going to relaunch the application. Okay, so this is a fresh database, so there's currently nothing configured. So we're going to go ahead and configure this station. So I'm going to select this default site one, and I'm just going to give it a name, and we're just going to call it training. So a lot of this other information is just metadata that we can enter in here. If we were submitting data directly from this station using the FTP-IE utility, we may need to enter information such as the site code and the lat and longitude. But in this case, this is just all metadata that you can enter if you would like to. You have some options down here at the bottom if you want to save the instant data to files, and then you could use the reporter program if you wanted to run reports against the instant samples as they come from the instruments. And then you have options here, the calc averages, how they're calculated. So anything greater than 1 minute or less than or equal to 60 minutes, calculate those averages using the instant data from the analyzers or the existing 1 minute averages that are already calculated. And then again, anything above 60 minutes or less than or equal to 24 hours, calculate using the instant data from the analyzers or the existing 1 minute averages or the existing hourly averages that are already calculated. So the first thing we need to do when we set up a new station is configure the time bases. So I'm just going to set up some default 1, 5, and 60-minute averages. So this tells the software that we want to create 1 minute averages, 5 minute averages, and 60-minute averages. And to the right of that, we see this maximum days back. The -1 means to keep the data indefinitely. If we only needed to keep a year of 1 minute data on this system at any given time, we could put 365 here, and it automatically checks the data that's currently in the system, and it will delete anything that's older than 365 days for the 1 minute data. Same for the 5 and the 60. So I'll change that back to a -1. And then you have some special time bases. If you wanted 5-second averages, 10-second averages, 15 or 30, you could add them here. So I'll go ahead and click save. And we'll start by looking at the users here. So the default user that's going to be configured on a new database is the standard administrator. We set the username as DRDAS when we created this new database. But if we wanted to add a new user, then we could do that here. Okay, and for some reason it's not letting me click off of this. So I'm just going to close and reopen. I think it's because I changed the username from administrator to DRDAS. So I'm just going to close and reopen it really quick. Okay, so the first thing we want to start with, I like to stay in the settings view. There are some other views, like if you quickly needed to see all the channels at the station, you could go to view and then expand channels and you would see them all in order there. Or if you wanted to quickly find an analyzer that's configured at the station, we'd go under this analyzer view. Typically, I like to stay in the settings view. So I'm going to expand communication. Least means anything that's RS-232 or serial. So if we had an instrument connected to COM port 1, we would click least, select COM port 1, select the default settings for that instrument. If you're not sure, you would look on the instrument and see what the baud rate is. So we'll say add port. That port will appear here on the left. We'll select it. We'll say add analyzer. We'll just go with an API. And let's say a T200. So we'll say add. It will appear there. We'll select it. On the properties tab here, the default settings, we're taking a sample from it once every 10 seconds. And you can adjust that as you need. And the default timeout is 500 milliseconds. So this is saying we'll send a command and we'll wait 500 milliseconds for a response before we continue. So on the device tab, you always want to verify the device ID on the instrument. So by default, we're just saying it's going to be 200, but you'll want to check that device and actually see what the device ID is. It may be 1, it may be 0, and you can do that from the front of the instrument. And then diagnostics, we'll say get the default list. So this will load the default diagnostics list for that T200, and we can tell it to collect every, I'm just going to say 60 minutes. So what that will do is every 60 minutes, it will take a snapshot of the diagnostics. They're not an average, it's just a snapshot at that time. And then I'll go to the digital status tab, get default. And then this is where we can set up an alarm. For example, if there was a sample flow error, we could check this alarm button and it would pop up on the screen that there's an issue with the sample flow. I'll show you later on where we can actually set up the system to send us an email or invalidate the data if there is an issue with the digital status. And then spare parts, it's not really used that much, but this is where you could put an inventory of spare parts for the instruments. So for this device, the T200, these are the registers that are being requested. You can look at the manual of the T200, and if you wanted to add more registers, for example, like flow, if you wanted to collect that as a channel, you would enter it there. So let's go ahead and add our channels, NO, NO2, NOx. So we'll select that first channel, NO. And then we see this list to the right. This tells us what register on the instrument to put into this channel. So for the NO channel, it'd obviously be NO. For NO2, we would select NO2. For NOx, we would select NOx. We'll save. So we'll go back to this NO channel. We'll put in units. I'm just going to put in ppb. This is just metadata that will display on the reports and in the Ultimate Viewer program. We could put in the serial number, the low and high range, the threshold. So 75% of the data has to be valid for the average to be valid. Same for the 24-hour threshold. We could select the pollutant type. If we're submitting data directly from the Ultimate, we could select that there. We could change the view format, how it's displayed in the reports in Ultimate Viewer, how many decimal places. And then your state, if it's on, it will collect the data as normal. If it's off, it won't collect the data. And if it's off scan, then it will collect the data, but the status will be marked as off scan. And then the average type for this instrument, it's just going to be typically just mean. For something like a BAM 1020, you would want to choose last sample. And there are several averages. If you were wanting to calculate vector direction or vector speed, you could select that. The EU conversion isn't needed for this because it's not an analog voltage. But if it was, we would select EU conversion and put in the voltage, for example, 1 to 5 volts or 0 to 5. And then linear correction. This is where we could add a correction to the data. If we wanted to convert it from ppb to ppm, we would just put in a linear correction here. And then under this value manipulation, you can do C# formulas to alter the values. There's a lot that you can do with this, and if you have questions about this, you can send us an email and we can help you with that. So I want to go over to this digital monitor status validation screen, and I'm going to say load monitor list. And what that does is it loads this list here that we loaded earlier. So for that sample flow, if we say active, it will invalidate that channel if the sample flow, if there's an issue with the sample flow on the instrument. And we could select any number of these statuses, and it would automatically invalidate that channel if one of those digital status bits come on. And then IO validation. If we have digital inputs or outputs, this is where we can configure them to invalidate the channel if those are on. So if you had a relay that you were turning on, you could set up on this screen when that relay is on, set that channel to, you know, calib or invalid based on if that relay is on or off. And then alarms, we say add new. This is where you could send an email if the channel is above a certain level. For example, and you can choose the interval if the instantaneous value is, or the 1 minute average, the 5, or the 60-minute average. So you could say if the 60-minute average is above 200, so we would say NO 1 hour average is above 200. The alert is enabled. This continuous means every hour that is above 200, it would send the alert again. Send alert means that it would send it via email or text message. And then send return to normal means that it will send a secondary alert that says it's no longer above 200. So if we don't select that, it will just tell us that it is above 200, and we wouldn't know when it goes below unless we actually looked at it. And you have some other options here. You could have it turn on a digital output or play a sound, or record or do a sound record. Some of our users will have this set up that if the PM goes above a certain level, it will record a video, of like on a camera that's outside the shelter, just to see if there's a bunch of traffic. So we'll move on to the NO2 channel. Again, we'll enter the units, ppb. We already selected NO2 as the referencing channel on the instrument. We'll go to the digital monitor status. We'll say load list. Same for NOx. ppb. Load the monitor list, and we'll save. So next, we will add a sequence. So actually, first, before I do that, I'll show how to add an instrument as TCP/IP as well. So if we connect an instrument via Ethernet, the configuration is pretty similar. We would enter the IP address of the instrument. So we'll just say 0.30. For APIs, the port is going to be 3000, and that's standard for APIs. You can check the instrument manual to see what its default TCP port is. APIs are going to be 3000. Your thermal IQs are Modbus, so they would be port 502. And then older iSeries, they're going to be 9880 or 9881. So we'll say add, and we'll say add analyzer. We'll go with a thermo this time. and we'll say a 49i. If we look at the device tab, the registers list is just 03. Again, you want to verify the device ID on the instrument itself. So we'll just call this channel 03. On the instrument, we'll go to the diagnostics, we'll get the default, collect every, let's say every 60 minutes. Digital status will load the default list. As you can see, this one's much larger. Say save. Say PPB. And we'll set the channel as 03, referencing channel. Go to this digital monitor status list, load the default, and that one's done. So if you had an instrument that was set up as RS-232, but then you wanted to switch it to serial, it's easy to just drag and drop the whole instrument down to an IP address, so you don't have to set it up as a new instrument. So move that back. So we'll configure a sequence now. So we're just going to call this a daily 0 span, state on, say add. So select our schedule type. I'm just going to select daily and every day. And we'll say it runs at 2 a.m. starting tomorrow. So in this case, I'm going to configure this to run the sequence or the calibration directly on the instrument, but I will show how to add a calibrator in and send those commands to the calibrator. So for now, we're just going to say send analyzer calibration commands. So it will send the commands directly to the analyzers. So now I'm going to go to the sequence tab, say add phase. First one will be 0. Next will be span, and then a purge, and then we'll do a sample. So I'm just going to leave this timing default 5 minutes between each phase. So we will assign this to the 49i. We'll call it ozone. So we'll expand the ozone channel. We'll select calibrations, and we can see that sequence there that we added. So we'll say add, and then it appears under that channel. You can set up validation limits. The default is the span difference percent of the range, 10%, or you can do the percent of the reference, this factor, percent in the range, the factor percent of reference. So we're just going to leave those default, and then we're going to select our calibration that we added under the ozone channel, and we're going to put an offset of 4 and a duration of 1. So what that says is this 0 phase will run a total of 4 plus 1 minutes, a total of 5 minutes. And then the next one starts. So the span runs for 5 minutes to 10. So we'll do 0, 9, and 1. And we'll just say 300 as our reference value. So we see that the 0 phase runs here for a total of 5 minutes. 4 minutes in, start taking an average for a total of 1 minute and compare it to 0. And then when the phase span starts, run for a total of 5 minutes. At the 9-minute mark, take an average over that last minute and compare it to 300. So there is one more thing we need to do to actually tie it to that analyzer. we need to select that analyzer and say send calib command. So we'll save that. If we wanted to perform a calibration and send calibration commands directly to a calibrator, what we would do is we would add the calibrator. So we're going to say we're adding it to COM port 2. We'll say add analyzer calibrators, and we'll just select API, and we'll just call it a T700. Select the device tab, device ID. You need to check the calibrator and see what its device ID is. I'm just going to put in 700, and I'm going to say send set command and use reset command for calibrator. For APIs, it's just C standby. Save. So we'll go back to this sequence we configured, and instead of sending the commands directly to the instruments, we're going to tell it to send the commands to the calibrator instead. So we'll select that sequence. We'll uncheck the send analyzer calibrations command, and we'll say send calibrator command. And we'll choose that T700. We'll save. So for the 0, we'll put in the commands, and these can be found in the T700 manual. C generate. I think it's actually ozone. C standby, C standby. So in the purge phase, we just tell it to go back to standby, and then the sample phase, go back to standby, and save. And then we would deselect this send calib command on the instrument itself. So now when this phase starts, it will send these commands directly to the calibrator. So I'll just cover this really quick, this alert settings. This is where you can configure how the alerts are sent. Most of our users will use our free, we offer a free SMTP server that you can use to send email or text alerts. And this is where you would configure that. So you would have to configure this first before any of those alerts could come as a text or email. So after we've saved everything to see our changes, if the service was already running, we would have to restart it. In this case, it's not running yet, so I'm just going to go ahead and start it. We see that it's running now, so we can open up the viewer. So when we log in to the viewer, we can see the site we created along with the channels. We're not actually connected to an instrument, so we're not seeing any data. So on this dynamic tab, this is where we can see the live information that's coming into the system. Our tabular, all sites, the digital IOs, we don't have any configured, but if we configure digital inputs or digital outputs, we can see their status here. We could see the digital monitors. That's the current digital status list of the instruments. So if there was an issue with the bench temp, we could see it would be red showing us that it's on this 49i. Same for the T200. If we look at its list, we can see if there was an issue with the sample flow or RAM reset. If one of those was on, we would see their current status. Diagnostics, we would see a current snapshot of the diagnostics here. Same for the 49i. We could set up dynamic charts that would update dynamically as data comes into the system. Then there's the dynamic viewer. It's just a kind of a dynamic display of the instruments at the site. And then alerts, we could see active alerts if a value was above a certain level, or if we set up the alarms on a channel here. For example, if the ozone was above a certain level, this alarm list would pop up and show that alarm. Under operational, this is where you could run a sequence manually. So if we selected the daily zero span ozone, we could say initiate sequence and it would run that full sequence. If we just wanted to run a phase on that sequence, we could select phase from sequence, select the sequence that we wanted to run the phase from, and then we could choose, just the span and say start, and it would only run that span phase. Start stop collection. What this allows you to do is it allows you to pause data collection on a serial port or on an Ethernet port. For example, if you wanted to connect to this 49i using Thermo software, because you can only make a single serial connection to a device at a time, this could tell Ultimate, okay, stop your communication with the device so that iPort can talk to it. So you would select port 2 and tell Ultimate to stop its data collection for 5 minutes. And then that allows you to then open the iPort software and connect to that instrument. There are other ways of doing that. You could stop the Ultimate service and then connect to it with iPort, but if you do it that way, data collection for all instruments would stop during that period. Whereas with this, if you just say stop port 2, only it would stop the communication and everything else would continue logging data. There's a couple other things here. The terminal command, it allows you to send commands to an instrument manually. And then under traces, you have the analyzer. So the analyzer trace, you can select an instrument and you could see what's coming back from the instrument. In this case, we're not actually connected to one, so we're just seeing communication failure. And then traces communication. This is very helpful when troubleshooting communication to an instrument. So if we were having an issue collecting data from this T200 on port 1, we could go communication port 1, and we can see in red our requests to the instrument. So Ultimate is saying T200 NOx, and it's not getting a response. So it's sending T, which is the command that the API is expecting, and then the device ID 200, and then the register. So if the instrument was responding, we would see a response in blue here. And it may respond with a different instrument ID. It may say T000 in the value. So that would mean that we're using the wrong device ID here. So we would just change it to match what the instrument is here. And then we would save and restart the service. Under tools, you have refresh, which is also here. If we were to go to this ozone channel and change it from ppb to ppm and save, we're not actually going to see it change here until we first restart the service. And then refresh the viewer. And this is the same for adding a new channel or a new instrument. After you add it in the setup program, you have to save, restart the ultimate service, and then refresh the viewer for those changes to take effect. So now we can see that it's now ppm. And then this clock is just an on-screen clock. Language, you can change the language of the software, and then manual pull. This allows you to back pull data on an instrument if for whatever reason the serial cable on the back of the ultimate or the instrument became disconnected and we didn't collect data for a week. You could reconnect it and then back pull the data from the analyzer. So to use that feature, you actually have to configure the IDAS tables on the instrument itself. So this can be done with, the API COM software, but you would set up those IDAS tables and say start recovery when data is missing for, let's say, 60 minutes, and then you would put in the table names on the instrument. So if the 1 minute data was saved in a table called 1 minute, you just say 1 minute. Say it's the 1 minute data, 60 minute data, and then save. And then options, this is where you could create a dashboard or dynamic charts. So if we say add chart, we could say NO, add. So we could have a dynamic chart as the data is streaming into Ultimate Viewer. We would see that chart changing. And then view, it's just, you can cascade windows, tile, close all. If you have everything closed, you needed your tabular back, just dynamic tabular, select your site. And then we'll go into the Ultimate Reporter. So when we go into Ultimate Reporter, it's similar to the viewer. We have this dynamic tab, and this is where we can also configure dynamic charts or dashboards that would update as data is coming into the system. And then you have the Reports tab. If we go to Sites, we will, let me see if I have data here. Okay, we have a little bit of data. So if we click Sites, and let's just go to the 13th. So the 13th, daily, the 13th, hourly data. Say okay. You can see that we have some data here. So this is an hourly report. If we press the space bar, we'll go into this graph, press space bar to return. So you have a couple settings here on the site report. You can choose tabular, which is what we see here. You can choose a graph. It just dumps it directly to a graph, or you can choose to dump it to an Excel. So it's saying that you must define the export path for the Excel file, so where it's going to save the file. So to do that, we need to go to Setup Options and choose the path. So I'm just going to say on the desktop. Go back, Report, Site, Excel, 913, 13. So it just dumps that report right to an Excel file. You can choose the average type, just regular average, min, max, running average, running min, running max, running forward, running min forward, and running max forward. You can also choose the from time base. So if you wanted to use the hourly data and create 6-hour averages or 8-hour averages, etc., you could do that there. You could click the status tab and say use the status criteria. And if you only wanted to see data that is okay, you could select that there, or any other number of statuses. You would just select those statuses and it would only show that data. If we say include statuses and say okay, we can see that it shows the value and then an underscore in its status. We could say status, separate status and value. Oops. Okay, I don't know why that's not working. Okay, so that should separate the status and value into separate columns, but it's not doing that. I'll have to take a look at that. So under reports, you have a number of other reports, a matrix report, instant report. So to use this instant data report, you would have to first have this configured here under the site. You'd have to say save instant data files every, so many seconds. And then you would have to have this instant data folder mapped here. So it's typically just going to be C Envidas Ultimate Instant. But to use that instant data report, you would have to have it enabled here first, or it's not going to work. You have a group report. So if you ran a lot of reports on just meteorological data, you could set up a group that only has the meteorological data so that you didn't have to come in here each time and then select the wind speed, wind direction manually each time. You would just go right into groups, select net data, and then run the report. You have an events report. If you wanted to see how many times the PM25 was above or below a certain value, you could put in a number there, say okay, it would give you a total time, or the total amount of times that occurred. You have a 2x 2y report, parallel report, wind rose report, wind polar, pollution rose, polar time and scatter, percentile report, a histogram, a counter, and a data report. So you're able to edit data on the Ultimate Data Logger. Most of the time that's done on the Envista Central system. But if you were to do edits directly on the Ultimate, this is where you could run an edit history report to see what values were changed. Operational, this is where you could run a calibration report. So 2-point summary, a 3-point, multi-point span versus 0, precision, all calibrations in one report, or converter efficiency. So this database may not be a good example, but if we wanted to see the calibrations that ran for ozone, we would select ozone, select 2-point or a multi-point and the date range, and then run the report. We could run a report on the historical alerts that occurred at the station. We can run historical diagnostic reports, digital monitor reports, or digital I/O. If you had digital inputs or outputs that were configured at a station, you could see when those were turned on or off. Missing data. This is just a quick way to see when the status was something other than okay. You could run a missing data report. And then the power off report. This tells anytime that the ultimate service was not running. Let's see if we can get an example here. So during these times on the 5th at 12:17 p.m., the service was off for 39 seconds. Here on the 13th, you can see that it was off for a long time. So if you are running a report on the data and you're like, why is all of this data showing no data? We should have data for this period. You could come in and run a power off report and you would see that, maybe the service was off during that time period. And that could be a number of things. Maybe a tech was at the site, they stopped the service while they were doing something and then they forgot to turn it back on. So anytime you're at the site, once you're done, you just want to make sure before you leave that ultimate service is running. And then you have a logbook. If you say add, you could add a logbook entry. If we click report, we could run a report on those logbook entries. So let's do it for the month of September. See if there's anything in there. Okay. So we can see this logbook report here on this database. It's just some test logbook entries, and we can see where users logged into the system and where they changed stuff in setup. You can see all the information there. Edit. This is where we could edit data on the ultimate logger. But again, typically this is going to be done on the Envista central system. But if we select edit table there, similar to Envista, we could select values, say open edit block, and we could set the value to something or apply a linear correction to it or change its status. And then the edit table, then you have the edit block where you don't necessarily see that table. You just say, during this period, I want to set the value to this. And then calibration, this is where you can edit a calibration or add a manual calibration into the system. And then tools, the connect, if you want to connect to a different database, you could change the database there. You could refresh the connection to the database, perform a backup of the database, or if you have a report up, you could go to tools and quickly dump it to an Excel file or to a CSV or export it to another or any other number of files like an ASCII or data CSV, etc. You also have this import feature. So in the event that you weren't collecting data from an analyzer and you didn't have this recovery set up here, you could export that data from the analyzer and then go to Tools, Import, select the file. I don't know if this is a good example, but we'll see. And go to Configuration. And then you could choose the date format. month, day, year, time, AM, PM, site, say site 1, and this is hourly data, so we'll choose hourly, choose the date, time. The first channel in this Excel will map to channel 1 on the Ultimate. Temp will map to temp, RH, etc. So this data was exported from this database, so all the channels are going to match up. But if this was a data file that came, directly from the instrument, there may only be one channel listed in it. It may be, just CO. So we would right click our CO channel on the Ultimate and select the CO channel. And then we would say, we would set the start time or the start row that we want to start importing data, and then the end row. And we would just say finish. And then we would save that data to the database. So under setups in the reporter, this is where we could set up group reports. Like I talked about earlier, like if we were running a lot of reports against the meteorological data, we could set up a met group. Dynamic multi-site, dynamic chart, similar to the Ultimate Viewer. You could set up a chart here, and it would update as the data is coming in. And then views, cascade, similar to the Ultimate Viewer program. So that's a quick overview of the software.